All right, in this video, we're going to be covering number 5 of 2017 for your response question. This is a particle motion problem. This is a non-calculator problem, which means there's probably going to be a lot of work here. So let's go ahead and get started. Number 5, it gives us some information. I'm going to write this down. X of p of t is equal to the natural log of t squared minus 2t plus 10. And then it also tells us v of q of t is equal to t squared minus 8t plus 15. So those are the two bits of information it gives us. And it says that this is the position of particle P, and this is the velocity of particle Q. And then it also gives us an initial position of 5, 0 for particle Q, but we'll get to that later. For part A, it says, when is the particle P moving to the left? So particle P is moving to the left when the velocity is negative. So because we're given position, we have to take the derivative of this. So the velocity of particle P, the derivative of this is going to be 1 over t squared minus 2t plus 10. And then we have to apply the chain rule here. So we have to multiply that by the derivative of the inside. So that'd be times 2t minus 2. So that is our velocity function. We have to figure out when that velocity is negative. So what we need to do first is find the critical points. So we're going to set this equal to 0. And I'm just going to move this on top here. So you got 2t minus 2 over t squared minus 2t plus 10. It would be nice if that factors, but it doesn't. The bottom line is, though, that this this velocity is equal to 0 when the numerator is equal to 0. We can cross multiply here if you need to see that. That'd be 0 equals 2t minus 2. And so we solve that and we get t equals 1. Now, for my understanding, I like doing a number line here. That is my only critical point. Our endpoints, well, actually, we do have endpoints of 0 and 8. And then we have that critical point of 1. So this is when velocity is 0. We have an endpoint at 0 and 8. And we are looking for when velocity is negative because we're looking for when the particle is moving to the left. So therefore, we have to figure out the signs in between in these intervals here. So you can just pick a numeric value here like 0.5 and plug that into your velocity equation. If I plug in a half there, 0.5, you would get, what is that, -1. And then 0.5 here, you're going to get 1/4 minus 1 plus 10. That's a positive. So here you're going to get a negative value because the top's negative and the bottom's positive. If I plug in a value in between here like 7, this is going to be positive, and this is going to end up being positive. So you end up with a positive there. So we can say that the particle, let's see, particle P is moving left for 0 is less than t is less than 1, since v of p of t is negative or less than 0 in this interval. All right, so that's the answer for part A. You're going to get 1 point. 1 point for finding the derivative correctly, and then 1 point for the correct interval. Now, they didn't say anything about justification, so I guess they can't ding you for not having justification, but you should be justifying it. It's good practice, okay? So that's part A. Part B, it says for for 0 to 8, find all times during which the two particles travel in the same direction. Well, this is dealing with velocity again, because if I'm moving to the left, my velocity is negative, and if I'm moving to the right, my velocity is positive. So they are traveling in the same direction. They're traveling in the same direction when their velocities have the same sign. And so we know the signs for the velocity of particle P are already known based on this number line. So basically, all we have to do is figure out the signs of the velocity of particle Q. So we're going to set particle Q's velocity equal to 0. So that'd be 0 equals t squared minus 8t plus 15. And then to solve that, we're going to go in factors. So you got 0 equals t minus 3 and t minus 5. Our solutions are 3 and 5. So we can set up another number line from 0 to 8. We have 3 and 5 as our zeros for our velocity of particle Q. This was particle P here. So we're going to plug in a point in between there. If I plug in like a 1, that will be negative and that will be negative. So this is going to be positive. If I plug in a 4, that's going to be positive. That's going to be negative. So that'll be negative. If I plug in 6 or 7, that'll both be positive. So that's positive. So now we know which direction each particle is heading. We're looking for the time interval for which they have the same signs. Well, in this case, we have a negative velocity from 0 to 1. Well, from 0 to 1, we have a positive velocity here, so that doesn't work. From 1 to 8, this is all positive. So from 1 all the way over to 8, we're looking for any positive intervals. So we can see that this particle will be positive from 1 to 3, and from 1 to 3 here, and positive from 5 to 8 here, and positive from 5 to 8 here. So we'd say our answer would be 1 is less than t is less than 3, and 5 is less than t is less than 8. And that is our answer there. It does not say to justify, so I guess that would work. I guess that would work for your answer. Now, points on this, you're going to get 1 point for having the correct, you're going to get 1 point for having the correct intervals. Which is that. And then 1 point for having the correct analysis using the two velocities. Okay? So now, normally, I don't know why they're grading it like this, because normally they say the number lines are not valid in terms of any kind of justification. But in this case, they are saying it's okay. Really, what you should add to this is when they're moving in the same direction, because their velocities have the same signs over those intervals. So that's part B. Oh, by the way, it was very clear here. It says you only get 1 out of the 2 points if you only have 1 interval. And of course, your analysis would have to be there. So if you only had this piece or this piece, but you had the correct analysis, you get the 1 point. And you would get 0 out of 2 points if you had no analysis. So in other words, if you had nothing that indicated the signs of velocity anywhere in there. So that's worth 1 point for A, or 2 points for A, 2 points for B. Let's go ahead and look at part C here. And I'm going to keep those equations up there. For part C, it's saying find the acceleration of particle Q when t equals 2. So let's go ahead and do that first. The acceleration of particle Q. Well, the acceleration is the derivative of velocity. So the acceleration of particle Q is equal to 2t minus 8. And it says find the acceleration when t equals 2. So a of q of 2 is equal to 2 times 2 minus 8, which simplifies to negative 4. So our acceleration of particle q at t equals 2 is negative 4. So that's our first thing. And then our second thing, it says, is the speed of the particle q increasing or decreasing? Well, speed is increasing or decreasing when acceleration and velocity have the same signs or different signs. So we have to figure out the velocity of particle q at t equals 2. So we're just going to plug that in here. So you end up with 2 squared minus 8 times 2 plus 15. So the velocity is equal to 3 when you simplify all that. So we can say since the acceleration is negative and the velocity is positive, the speed is decreasing. So the speed of particle Q is decreasing when t equals 2, since a of q of 2 and v sub q of 2 have different signs. All right, so that's your answer there. As far as point goes, you're going to get 1 point for finding the correct acceleration at t equals 2, and then you're going to get 1 point for your answer with your justification. So 1 point for just finding acceleration and 1 point for stating that the speed is decreasing because acceleration and velocity have different signs. So that's part C. Part D, it says find the position of particle Q the first time it changes direction. Well, we actually need some information from part C, because we know that the particle, let's see, Q changes direction, or sorry, Q first changes direction when t equals, it was t equals the velocity when t equals 3. Okay? And going back to that real fast, you had that number line that said 0, 3, 5, and 8. And the velocity of Q was positive, then negative, then positive. So this is the first time it changed direction, was at t equals 3. And so remember, to find the position, we need the position of particle Q, let's see, when t equals 3 is equal to our initial condition. Now our initial condition, according to the prompt, was 5, and then plus the displacement. So plus the integral from 0, because that was the time of our initial position. So I'll write that down off to the side. From 0 to 3, v of q of t dt. So I know all these subscripts, the q's and the p's and everything, make it just a little bit more difficult for our brains to process, but they're there for a reason, because we're comparing two different particles. Anyways, so the position at 3 is equal to 5 plus the integral from 0 to 3 of velocity. And then from here, we just need to solve this. Now, I'm going to rewrite this as 5 plus the integral from 0 to 3 of my velocity function, so that's t cubed minus 8t plus 15, and then that would be dt. So because this is not calculated, we got to take the antiderivative here. So that's going to be equal to 5 plus 1/3 t cubed minus 4t squared plus 15t, evaluated from 0 to 3. And then we go ahead and plug in the values, the upper bound and the lower bound, and then subtract. So that'd be 1/3 times 3 cubed minus 4 times 3 squared plus 15 times 3, and then all minus 1/3 times 0 cubed minus 4 times 0 squared plus 15 times 0. And so we simplify that from there, but in all reality, I've told you before, once you get to an expression with just all numbers, all constant values, then you can just leave it like that, and that is your final answer. But just in case you did simplify it, your final answer was 23 when it's all said and done. As far as points go on this problem, or for part C, sorry, this is part D, part C. For part D, you get 1 point, 1 point for the correct let's see, 1 point for the correct antiderivative. That's weird. Okay, so 1 point for this. You're going to get 1 point for using your initial condition. So basically in your original statement that you had 5 plus the integral from 0 to 3. And then 1 point for your answer. All right, so that's part D of number 5 on year 2017. So for the next one is going to be a quiz. You need to do number 2 of question 2018. Set a timer for 12 minutes. Do this all on your own. This is a calculator-based problem that you're doing. And then go ahead and watch the next video to grade yourself.